of the muscular. And as well, I'd like to acknowledge, or I would ask others who are on Zoom to acknowledge where they are as well. The first presentation today will be Neha at IRES, who's been working with me on the question of electronic repair. Neha has a master's in economics. She worked on a variety of policy questions in her career in India, moved to UBC to do a PhD. She's a Shirk Fellow. She's a Peter Wall Scholar. Were you a Liu Fellow as well? No.
I think so, yes.
Yes, she was a Liu Fellow. All sorts of fellowships that attest to her capabilities. And she's also teaching, even as we speak, or in the afternoon today, ASIC 220, which is the Introduction to Sustainability class that IRES runs. Welcome, Neha.
Thank you, Milind. Thank you so much for that kind introduction. Thank you, everyone, for coming here out on a really sunny day, a rare one in Vancouver. So it's nice to see you all here and the folks on Zoom. Today, I'll talk about my PhD project as a whole, which is focusing on repair, specifically in the context of electronics. And is this better? Okay. So specifically in the context of electronics at the end of life, and I would try to sort of capture it more like a story and the themes in the research rather than the actual results and the methodology. So first I'll start with setting some of the context through the academic research and policy discourse, and then move on to the rest of it. To start with a sense of scale, of the e-waste that we annually create at the global scale in terms of mass is close to 6,100 Eiffel Towers worth of mass. While relatively the smaller share of the overall global waste streams, it is one of the fastest growing waste streams for over a decade now. It's also a challenging waste stream because the components of e-waste are often hazardous, containing lead, nickel, cadmium, mercury in the e-waste, making it crucial to minimize volume, not just for the environmental, ecological, and economic reasons, but also because it has health, labor, social, global and local justice, and equity concerns that often impact the marginalized communities across the globe the most. So while so far we have looked at the volume and the nature of e-waste, we also understand from research that the majority of waste when it comes to electronics, as with a lot of other categories also perhaps, is generated before a device or an electronic is actually even sold to a consumer, before they purchase it also. And this manifests in the form of the pre-consumer waste in the form of the extraction of the rare earth and the critical minerals that come from across the globe and then travel to their component manufacturing and the final manufacturing stages. Then in the actual manufacturing and assembly stage of the components and electronics. And if we look at even the self-reported data of some of the manufacturers of electronics, especially as we go towards complex electronics, the production phase contributes to more than 80% of the emissions or the waste that get generated from the entire lifespan of an electronic. Given that most of the environmental damage actually gets baked into a product before it even is purchased or touched by a consumer, one would assume that the policy focus and the general trend overall would be to ensure that the products are durable, they have longer lifespans, and are repairable when they can be, so that we can salvage their value and contribute more towards value preservation. But research actually suggests that electronics lifespans and repairability have been declining over the last 2 decades. So given this context, my research focuses on the repair piece, which is sort of the bridge between the production and the waste space. If we look at the repair ecosystem, there are 2 separate sides that we can look at. One is the supply side, which comes from the OEMs or the original equipment manufacturers or the producers. They also impact demand by creating the products that they do by making them repairable or not, or shorter duration ones, or actual durable, long lasting ones. And the other side is a demand side, which is consumers, which decide to repair a product or not when it faces a damage or not. And underlying all of these is also the rule setting space, where the big player is the government and the policy space, which set the market conditions for the industry and consumers to take the decisions that they do or not. So my research actually looks at these two buckets, the consumers and the government. Before I actually start to share the results, also wanted to just bring to focus the way industry actually has an impact on the repair aspect, because they obstruct repair through a variety of ways. Some are actual product design decisions through hardware, like gluing of parts, customizable proprietary parts and tools to handle them. Then there are the system design aspects, making the software such that you can only get stuff repaired from their authorized repair networks and not from independent repair networks. And then lastly, by influencing the actual repair options availability by making spare parts, tools, and stuff either unavailable or too expensive. The reasons why industry often says this happens is because of IP protection, safety, cybersecurity, and liability and reputational harm, which could be bucketed in a legal and policy space if we look overall. And the other aspect, the reason they cite, is that the consumers actually don't want longer lasting repairable products. They want the newer, shinier product the soonest. So we create such products. And that's the part that I look at when I'm researching this piece. There are two aspects of research. One is the consumer piece, which is where I look at whether people repair electronics at all or not. To just set like a baseline survey, there are surveys and data that exists in the European Union and a lot of Asian countries, but in North America, there isn't a large scale survey that I found which substantiates this well. And what are the determinants of repair is the second piece. This is a quantitative study based on an online survey in North America with a sample size of 1,516. And I looked at some descriptive statistics, factor analysis, and logistic regression. I had to choose one category because electronics is a big set of products. So I chose phone because it's something that all of us have. Most adults across the globe now have. And it's one of the complex and evolving technology, which sort of typifies what we've seen through the context. Jumping into some of the results, what we see that there is some repair resiliency that we've seen in the North American market, despite the lack of supports, which I'll get to in the later part. So pardon that I've brought it up already. But from the sample, that flowchart just shows how it sort of breaks down from the phones that are damaged or not damaged, to say that 50% of the sample repaired their phone. While this number might seem like a small number, it's still, if we compare it to some of the other studies that have been done in European Union, the rates of repair sort of range from anywhere from 12 to 34% to 75%, and close to 60% in some of the countries where legislations are slightly different. We also saw that it's a complicated decision. Each of us make that decision based on the perceived importance and functionality of the product and the damage that it has caused. So most commonly repaired items, as perhaps all of us already sort of know, are the screens, batteries, and the charging ports. There's also a little nuance in the data that not repaired isn't actually meaning that it's replaced. 92% of the respondents actually chose to not replace and either repaired or continued degraded use. So this brighter green bars are the equivalent of the 50% we just saw. But these lighter green bars are the folks that are continuing to use their phones despite some damage. with degraded use. They don't want to straight away replace the phone, and which means that they either just carry like their battery around all the time if the battery is dying out, or charger around all the time, and they come up with innovative ways to sort of go ahead with that. Moving on from the past or the actual behavior to what they showed, or what they spoke of the future intent to repair. 60% of the sample, on the average, across the damage types, said that they would continue to repair the product if they faced a damage in the next 6 months. And the damage and the percentages were higher for the most common damage types as well, going up to 68% for screens. So we've seen that there is an intent to repair, but what's happening? What is actually the barrier that most people face when they choose not to repair? The story seems to be financial mostly, that when they were to rank the barriers which actually mattered to them the most, whether when they choose to repair or not repair, cost, search, the action of search, and then trust in the ability of the repairer, time, trust in security, and access. Cost was the highest ranked one across the sample, followed by search and trust closely together. Moving from barriers to looking at the motivators for repair, why do people actually repair? The story was again financial factors were the dominant reason here as well, where most people were saying that replacing with a new phone is too expensive. I don't want to spend money on a new phone for marginal future improvements and things like that. We did see some folks talking about finding satisfaction in fixing and maintaining the possessions, but the irresponsibility of adding to e-waste or the environmental concerns were slightly lower as compared to the others. Demographically, I did not see statistically significant differences across gender, age, and ethnicity, and the only variable that sort of stood out was the household income, where we saw that the middle income 3 brackets, these are not really middle income, they're actually upwards of 100,000, and this is US dollars. I'm sorry, I haven't mentioned it. US dollars 2023's constant value. So these are the income brackets where it was actually repaired the most compared to the others. So the low income bracket and the very high income bracket is where we saw lower rates of repair. In summary, I would say that the sample suggested resilient demand, where half the sample repairs despite zero policy support, and only about 8% on an average actually intended to repair. People tolerate degraded use and prefer to continue to retain their device. And it seems like repair is an economic survival strategy driven mostly by costs and income. So repair gap so far did not seem like a gap of intent, as was the story or the rhetoric that comes from the industry and the OEMs, but a gap of viability on a lot of factors. Okay, this is just a repetitive thing, sorry. Moving on to the next piece of the puzzle, next piece of the research, from the micro piece to the macro one, which is, in here, I looked at the regulatory space for electronic repairs. How are the electronic discards actually regulated? And do these regulatory systems actually facilitate repair? How should the space be regulated? Through literature, I understand that there are 2 sets of interventions upstream, which happen before a consumer buys a product, and the downstream ones after usage. Upstream interventions are a part of the right. Some of the interventions here are right to repair bills. However, they actually only impact the availability of repair tools and not actually repairability. For impacting repairability and durability, policies impacting that design, like the eco-design regulations of repairability and durability indices and labeling and standardization, are the policies that are being adopted already in European Union for the last 5 to 10 years. And those have an impact on actually making a dent there. And in the interim, we don't want to lose the entire independent repair industry and their intent to repair. So income tax rebates for repair spending and value-added tax reductions for repair services are prevalent in the European Union, some countries. It has as a last resort, the downstream intervention of ensuring that when the product has to be discarded, it has to be done in an environmentally safe manner and handled appropriately with labor and health conditions. So we need to ensure that we have our recycling infrastructure in place for that. I've looked at the case of BC to understand how it's actually regulated, moving on from like the theoretical should to how do we actually do it. So BC is often considered the gold standard in North America when it comes to waste management. And if we look at the goals and objectives, the ambition actually aligns with the waste hierarchy of reduce, reuse, recycle. And the regulation objectives also echo the ambition, where we see this from the BC recycling regulation. The regulatory space actually comprises of several levels of government, as is a typical scenario for most spaces here in Canada. The federal level has a jurisdiction over the overall directives, the right to repair space, and the transboundary movement of hazardous e-waste. Provincial government sets the EPR legislation. The municipalities and the regional districts actually help in the operationalizing of it. And then is the producer responsibility organizations, which are the industry stewards comprising of a not-for-profit body of all the OEMs in this space. What it actually looks like in terms of the operational flow of discards, there is the 8 PROs and the PC government setting the space there. When we deposit any of our electronics at the end of life to the take back or the take back options that are provided by the PROs, it can have 2 pathways. A secondary pathway of certified refurbishers, which currently is less than 1% of e-waste in BC goes towards that. That's just a charity of computers per school. But the primary pathway is recycling, where with the certifications, mandatory certifications, we ensure that it is dismantled, separated, shredded, and then sent to the smelters. There are 4 smelters, 4 recycling operations, 3 in BC and 1 in Alberta. And outside of this policy space, something that's not regulated at all are the independent repair shops and repair cafes. But the repair cafes only receive little funding and sporadic funding. And it doesn't come through the waste management bucket. It comes through community service and a different sort of programming. In terms of system performance, here in BC, we're collecting 3.4 kilograms per person of e-waste, which is higher than the Canadian average. The network coverage, as per their own annual reporting of EPRA and the other PROs, is a very high network coverage. There's enough collection networks everywhere. It's a consumer-funded logistics. One thing I have forgotten to mention over here is that the entire system is actually funded by the environmental handling fees, which is what we pay every time we buy any electronic. If you look at it, just like the recycling fees for our milk cans, we pay the same for all electronics, and that funds this entire system. But where does it go? 95% of it goes in actually managing the system, and only 5% in the bucket. So we do this well, but we do the recycling well, but nothing on the upstream side. And I think with that, I'm going to stop because I have run out of time. So I'm just going to leave some room for questions because I don't want to have no time for discussion. Okay.
Yeah, come back to the beginning of the presentation. In terms of the typology of waste versus right, sort of how you differentiate the waste for fraction.
Yeah.
But it sounds like you have a more efficient technique from a pollution early on and more physical waste.
Okay. Yeah, thank you for that question. That's a very good question. Also, one of the, I think just to repeat the question, trying to understand what's the, no, okay. So, just one of those things. When it comes to waste, we're actually looking at what is the composition of waste, what are the different things. But a lot of these inventories are still focused because they're done by environmentalists, perhaps, or at the people who are working in this space. The discipline sort of ensures that when we do an LCA, we're looking at it from an emissions point of view. So everything is sort of translated into those values. And that's what we report. So even the annual reports of any of the OEMs, when they do the reporting, they will say what were the emissions that happened during the extraction phase, during the actual manufacturing phase, and then the transportation and logistics and things like that. Does that answer the question? No, no. Yeah. Yes. Yes, it totally did. I think in the survey, the average age of the phone for the sample was 1.8 years. Uh, it was, when we broke it down into brackets, we saw a very high proportion in up to the 3 years, 3 to 4 years, and 4+ years, we saw 7% each of the sample owning that old phones. And when it came to folks who did not want to repair their phone because of the wording of the question, because it was next 6 months, it also was the reason was not repairing because of other reasons, but because they thought that it's coming towards the end of its life. So it doesn't. So the rest of the analysis sort of ties in with the age as well. Neha. Okay, so two parts. One, whether it showed up at all. One of the questions was regarding the warranty, and I think this insurance would perhaps sort of get caught in that bracket. And when we spoke about the motivators and reasons of choosing to repair or not, that was one of the higher uh, reasons as well. So folks who had plans where they were covered under the warranty did actually go ahead and repair because of that. But whether it actually has an impact or not on ensuring that the system works like that, I don't know if I can comment very well on that, but my hunch is that perhaps not, because of the way it is currently designed. They're designed perhaps in a way to just extract a lot more value from the consumer and not necessarily give back as much in return, because a lot of the common repairs are not always covered under these insurances with the reasons, and they always have these technical. So I don't know, with the current design, they are actually possible to make an impact on this space, but it did show up in the survey as one of the reasons why they did choose to repair their devices. Any more questions? Yeah. Yeah. BC, oh, you mean to say the province? Uh, they don't make any money. So the entire the fee goes to the PROs for actually managing the system. And they spend 95% of it in actual logistics and stuff. Thank you. Thank you so much. Where is yours?
Delighted to introduce Jessica Mukiri, who's, as you can see, decked out in her regal gala today, regal gear. Just came to UBC from Kenya. She did her bachelor's in biology and a master's in environmental science from Kenya. And then she worked for a few years at the International Center for Tropical Agriculture, CIAT, one of the CG centers, if people know that. She worked as an environmental modeler in their forage improvement programs in mixed crop livestock systems. So with that interest in kind of livestock systems too, she came to IRES to work on a project on sustainable livestock systems. She, soon after getting here, she got fascinated by the idea of alternative proteins. And so you'll hear some of her PhD work on that. You'll hear one part of the work today on, which is a more of a quantitative analysis. But then she's also been working very closely with Terry on a project, a more qualitative project, where she's been interviewing farmers across BC on their perspectives on alternative proteins. And for that, she's had to learn to drive, and bravely has been driving around BC doing her interviews. But over to you on the quantitative analysis.
Hello, can everyone hear me? Great. As you've heard, I'm Jessica or Jess. And yeah, so I was interested in this topic of alternative proteins. Quick question. Has anyone eaten an alternative protein? Okay, so people ate the pepperoni at lunch, pizza, great. So why this came to mind is we all know about the different impacts of climate change. Drought, flood, wildfires, and we all know about how we need to decarbonize, and we also need to decarbonize or find ways to produce better and eat better, and specifically animal source foods. When this is, we're talking about meat and dairy, predominantly in high income countries like Canada is where we have a big consumption challenge. And we see this as in Canada, we are consuming double the global average of meat. And this reflects also in our emissions. So we have double consumption emissions, again, globally, and mostly driven by consumption of animal products. And this results to about 39 metric tons of carbon if you think about all the adults in Canada. So the thing is, we have done studies where we know if we ate more plant-based foods, that we would be healthier, live longer, and basically good for the environment. However, changing diets is really hard. People like meat. We like the way it tastes, like the appearance, and we also kind of know how to cook these things. I think over the years, cooking things like legumes might not be the norm here, so it is difficult. So what do we do? So that's how I stumbled upon alternative proteins. And the idea here is that alternative proteins are meant to mimic the taste texture of meat, and they're made from plants and in different ways. So you've heard of like lab grown or cultivated meat. And these are some of the different products that I assume people have seen or tasted. We have like the Beyond Burger, the Impossible Burger, and these I think mimic meat well. So so I think they've done a good job. So I was kind of curious, does this actually do anything for our consumption emissions? And so this is kind of the question I was thinking about, like what do we actually eat like on a day-to-day in Canada? What are people consuming? And if they replace that, not change their diets, just substitute it, would it actually change our emissions? So how did I go about this? So basically, I did a baseline and some scenarios. And here I used dietary intake data, food emission data, constructed my baseline and carried out the different scenarios. So for the dietary intake data, we have what's called the Canadian Community Health Survey that was done in 2015. And what basically happens is that they ask you what you ate AM, call it AM to PM. So they kind of ask you, what are you eating the whole day? And they do this across the different provinces and for all different ages. But for the purposes of the study, I've specifically focused on adults and over the age of 19. I didn't include any supplements that folks were consuming. And they also do ask different days of the interview. So they call day 1 and day 2 recall. And for the purposes of the study, I just looked at one day on average, what are people consuming in one day across Canada. And then now for the emissions, for getting the food emissions data, I went through and looked for different papers and different databases that collect food emissions data in terms of CO2. And these are specifically LCA studies or life cycle assessments. And I was looking specifically for studies that had Canadian assessments for these animal foods. And because there's not too much on alternative proteins in Canada, I looked at this more globally for their emissions. So, and then from there, I extracted the data. And with LCA data, it looks at the whole life cycle. And I was specifically interested within these stages in terms of cultivation, processing, and then getting the product. This is called an extrude. This is for plant-based meats. And the equivalent would be chicken meat. So when it's slaughtered, basically when it has no bones or anything. So looking in terms of like the feed that's needed, the husbandry, and also then what happens when we get chicken meat. Then with all of that, I harmonized those emissions to get the total emissions. And again, this is mostly because consumption emissions, which also include like cooking or buying things from the store, account for under 20% of the emissions when consumption emissions. So for my baseline, I took that, and then I wanted to compare, okay, so if we switch from this to this, what would be the difference and at what different levels? So 5, 10, 20, 100%. So what did I find? So first of all, I found these are the different emissions per kilogram of food for these different meat products. And this is what I found for the plant-based extrudes, so what I was looking for. And I do want to mention that Canadian farmers are doing a really good job. These are very hard numbers to do. These are just trying to make sure that these systems are pretty efficient, but even as efficient as they are, these are still resource intensive products that we're consuming. And what does this mean in terms of our diet? So in terms of like all we're eating, and this is also like including beverages, meat takes up about 4% of our diet. So this is in Canada. And what kinds of meats are we eating? So a lot of ruminant meat in terms of beef, lean beef and ground beef, lots of chicken. And these are processed meats in terms of they do contain probably some chicken, some pork, some turkey. And these are like luncheon meat, salamis, ham, bacon. So these are across here. And this is about, in total, about over 100 grams a day. And what does this mean for emissions? So meat takes about over 50% of the emissions from our diet. So that means that we have a lot of work to do here. And everything else that's not meat in this situation, and also I forgot to mention not fish either. So fish is here, and then non-meat is less than 44%. So, and dairy is also there. So you can still have your cheese and your yogurt. So I'm not touching that. And I wanted to do again, which kinds of meats are basically contributing to these emissions. I think beef was going to be the culprit, but this was even across lean and ground beef. And we do see that, yes, chicken or non-ruminant stew do have some emissions too. So now that we kind of have this baseline, I wanted to know, okay, what happens if we wanted to switch just all the different meats, all these meats, what would happen? So this is kind of what happens if we just reduce emissions, and this is just a swap. 100% we get half emissions gone. So basically this is our new baseline, which would be like very great. But also like even just 12% is not too bad, or 25%. So some reduction if you just changed from all the different kinds of meat just to like 25%. So then I was curious in terms of like, okay, what if we look at the bigger groups? And of course we see that with here, we don't get as much reductions in this is the process and the non-ruminant meats, but with the ruminants, we get a lot of leeway in terms of how much we can reduce our emissions by. And then I wanted to know, okay, if we look at the different kind of categories of meat again, we can see that, yeah, maybe we can still eat some chicken, but maybe we need to think more about changing things like beef and some of the processed meats too. And I wanted to know overall, if we did this, all the adults over 19, again, anyone under 19, eat what you want to do. What would be the difference? What could we save? What could be the difference in emissions? And there are quite a number of differences in terms of like, yeah, we can reduce our emissions by 19%, 12% just by changing by 25% of all meat or of ruminants. So what does this all mean in terms of all these numbers? So, like I said, ruminant meat, big issue. We need to focus a lot of issues here. And like I said, farmers are already doing a good job. They've been reducing their efficiencies year by year. So we need to change how we eat. We see that if we looked at just beef, 25% substitution of beef, that 3.2 is equivalent to like removing over 700,000 cars from the road. And to give you an idea of that, I looked at what does it mean in Vancouver, like how many cars roughly like in Vancouver, that's like 1.7 million or 1.4 million. So like removing half the cars in Vancouver is like substituting just beef 25% of the time with these alternate proteins. So that's like I find like such a small, like such an easy, well, I think like a nice kind of shift. And again, and this can also help us reach our climate goals too. So, and that's just a simple thing of like, every time you, let's say you eat a burger 4 times in a week, 1 time in a week, just eat a plant-based one. It's kind of what I'm saying. You can still eat what you're eating all the other times. Just a small shift can actually contribute to changes and hopefully to decarbonize our food system. So that's me. Questions?
Or is it likely that
So I think you should come from my other talk. That's on my 3rd chapter. But I can quickly delve into that. I think the challenge here too is that I think there's room for both of the systems. I think we just have to be smart about it. And what I mean by this is that also when talking to different farmers, they actually like managing smaller herds of animals. So if they have smaller herds and they get a premium price, that's not necessarily a big issue for them, right? So it's not, I think there's a way that they can both coexist. And in terms of the question that you're asking, there's actually in the Netherlands, they've opened a precision or a cultivated lab-grown production system in a farm and converted the barn to be producing this. So I do think other people are looking at that in terms of like, how can you actually integrate some of these systems? And the farmer still has like some of the cows out there, and then on the barn, he has this. So can kind of work. I would say I wasn't focusing on that too much just because keep eating those. Those are good. You don't need to switch from whole foods to processed. No. I would say that because like in this case, especially I was looking at like more plant-based. So most of the crops, the peas, they have low emissions, right? So the emissions were coming more from the processing too. So if you don't need to process, just eat as a whole food. Go ahead, Anna. So I would say that interestingly, like in Canada, that there's, I think globally in terms of the OECD, the Canadian government is investing a lot in these industries, like in terms of production, but interestingly enough, not pushing as much for consumers. And why I say this, because like the shift is like in South Korea and in like in the Netherlands, not the Netherlands, Denmark, and also other Asian countries, you are seeing governments actually trying to encourage more of these alt kind of proteins, and this is coming, I guess, in more of like in institutions and the likes, and kind of saying like, yeah, this is good, like we want to do better, just eat it, this is good for the environment, these are important for us to do this. And I also think, even like for instance, like in Germany, they are seeing like younger people consuming more of these products, like interesting shift here. Younger people are like complaining, so I do think it's more of a sense in terms of like governments here being more reluctant and kind of telling people what to eat, I guess. So yeah. So like that's what I was saying, like it's more or less by half. Yes. So basically what we're saying here is that this plant-based extrudes, and okay, so one of the things that I found that was interesting, like especially like the Beyond Meat, because I didn't look at the full burger, because the full burger also consists other things like spices, etc. And I found that what is interesting, like in the Beyond Meat or some of these other products, was like the coconut oil or that they were using had higher emissions than like this plant-based extrude, right? So some of those things actually had higher emissions than that. So in that sense, it would be, you're probably reducing, I would say probably between 30 to 50%, depending on the other things that they mixed inside there. Yeah, they did, like in their LCAs are pretty detailed in terms of like, this is what they, most of the time with the Beyond, the IP is kind of how like the blending of things, but they'll tell you how much energy they use to do that. So then you can get an idea, if that makes sense. Oh, okay. So the other talk. So two things that I thought it was interesting was like, one of the farmers was like, actually, I think we should focus on more, like I think the way they looked at it is like higher quality meats should be left to farmers. And this is like prime cuts and all these other things. But then there, I think some of them were like, but the other things they call like more lower quality meat, like chicken nuggets or something like this, they're like, those should be left to something like this. And I was like, in my mind, that's something that I've been thinking about. But then hearing that come from farmers, I was like, oh, okay. So they're not as opposed to it. And they did see, I think one of the things that I will take away, and I think I tried to highlight that, is like, I think farmers see that they're producing nutritious food. And I think some of the way this has been positioned is like this against this. And I think for some extent, it's more like, no, how can we make both of these things work and not necessarily pit them against each other so much? I would say that was like one of my takeaways. And fortunately, that was the last question.